2 minutes is enough.
Okay, please write your name.
I'm the leader and also the reporter here to report the topic about ear muscles. First, it's still a problem statement. So, place a balloon inside a cylindrical neck, as it's sometimes to wrap up the collar, and inflate it. Then the neck will expand and shorten. The problem statement asks us to investigate the property of such a muscle. So, first we look at the showing picture here. At the beginning, the ear muscles will look like a totally straight line. Then if you inflate the air or other things inside the balloons in the beginning, then it will start being shortened. So because this problem statement asks us to ask about the muscles, so we have to look at what real muscles really work like. So the next thing I'm going to talk about is the property of the real muscles. So I basically will consider two things in the real muscles. The one thing is about the shortened part, which means that if you use your power, if you want to hold up the things or you want to use the power in your muscles, then your muscles will be shortened. That's the first thing I will consider. Then the second part will be the concentration. I mean, to become wider on the length, on the width part, which is shows in here. Because at the beginning, here it looks more lengthy, and on here this looks like you have a width. So that's the 2 points I will consider in my ear muscles models. So the next thing I'm going to talk about is an anisotropic and isotropic deformation. So what does this two nouns really means? So isotropic means that the property of our models has relation with a certain direction. So like in this picture. So like in this picture, the main direction will goes in this direction. It wouldn't go like a straightforward, maybe a tilted line. But if you look at an isotropic, it means that it will deform on any possible direction. That's the 2 points. So what's the reason I talk about these two properties and these two methods? It's because today, if we want to make a ear muscles model, they must have a relation with the shapes of the balloons. So first one I'm going to talk about is an isotropic deformation about the balloons. So this is balloons, for sure. But look, what's the difference with the ordinary balloons? This balloons is more lengthy. How to say that? Because so we look at the line. balloons, the balloons will go bigger on the length, on the vertical sides. So meaning that it wouldn't have more inflate on the width side. This is not the muscle I wanted because I mentioned two things. First one is to shorten, but because of the limitation of the neck itself, so meaning that it wouldn't expand on the vertical side, which is not correspond with the real muscle. So this one is the one I'm talking about, the bad, or not the bad, just the air muscles we are not going to talk about. And next one is the isotropic deformation. If you look at this balloon with a smile face, this balloon, I mean, it's not really totally isotropic because it still has its limitation on the each side. You can see that. Still, on the vertical sides, the balloon can expand more than the width side. But if we wrap the balloons with our cylindrical nets, I mean, even though on the vertical sides, the balloon still be restricted by the nets, but it can still inflate on the horizontal sides. So this model was what we are talking about in the later experiments. So these two equations will be the 2 points I'm going to talk about the deformation of the air muscles. So I wouldn't quantify many numbers in the air muscles because in this experiment, I will mainly focus on why it will happen, then what's the exact number of each figure. So we have two research concentration in our topics. So this is the other layer. I have to say sorry about it. But first one is the layer of the cylindrical net. What do I mean by layer? If in the air muscles, the amount of the cylindrical net you wrap on the balloons is uncertain. So we want to see that if I have 1 layer, 2 layer, or 0 layer, what will be the muscles looks like? And the second part, we want to cut some symmetrical holes on the cylindrical nets. If it looks at the air muscles on the above, I mean, if it looks like that, then we'll call different holes. I mean, not different holes. We'll call a symmetric hole maybe on this point and this point, this point and this point, to see that how it deforms in the air muscles. So these are the materials I use in the experiment. So first, for sure, the foam, the brackets, for sure the two balloons. These balloons I have talked about before. The lengthy one is the one that we won't use in the air muscle. We will mainly use the one that's the yellow one. I mean here. I mean the shape like the yellow one. And also the cylindrical net, the syringes, the 3-wheel valve, which is how we inflate the air inside. So first, it's our step. So we place the balloons inside the nets, and we attach the balloon to the opening 3-way valve and seal it tightly. Use the syringes to inject the air, which will inject every time we inject 175 millimeter each into the balloons. And last one, we'll measure the length change in the balloon. So in the later experiment, we are more talking about the length than the width, because that's how we see the shortened phenomena happen in the air muscles. So the length we define will be from the way we seal the air muscles is using the rubber to seal it on the 3-way valve, and we'll see the length will be from the rubber to the top part of the balloons. So first is this is the first variable. So we change the data wrapped on the cylindrical net. The control variable includes the balloon's shape, which I said is the drip one, and the material of the net will ensure that it's all from the same grain and just the same nets. And the next one is the valve injected each, which is 175 millimeter, I said, and the focus will be on the length of the balloons. So this is the figure we see. I have to make some explanation on it. So on the top part with the X in here, this is the balloons that didn't wrap by the layers. So it's obvious that if you inflate the balloon without any restriction, the balloon will just expand everywhere. So meaning that its length will become bigger. But if we look at the one that with 1 layer and 2 layer, how come it becomes shorter afterwards? Because if we imagine like balloon should be expanding everywhere. So this is how we gonna say about the balloons. Still the same picture, but we consider that there are 4 pressures that will be included in the air muscle spread. The first one is the atmospheric pressure, and the second one we will say is the surface tension applied on the pre-unit. So it's like maybe some certain area, this part the net keep the tension to it. And the third one is the surface tension of the balloon itself. We will also restrict the balloons inside. And the last one is the balloon's air pressure, which will against the whole pressure in the above. So on this about a geometrical part about the balloons. So because the neck itself is cylindrical, so when the balloon is inflated, it will firstly touch the above part of the here. And if we look at each geometrical structure of the neck, firstly it will become like this. And if you inflate it, the balloons become bigger. Then the geometric structure will become like this. And in every part of the balloon above, you will see that. If we look at the size that's more tilted, it will provide components on the y-axis, which will make the balloon become shorter. So that's why when we look at the air muscle, it will have a shortened phenomenon. So the second variable is what I said, the cutting points of the cylindrical neck itself. So the way we will cut the neck is we will find a connecting point of each geometric structure, like here is a connecting point, here is the connecting point, and we ensure that each time we cut the neck, it will be 6 connecting points, And still, the control variable, just like the last experiment. Also, we are going to observe the leg. So the reason why I want to see the cutting hole about the air muscle, because I want to see that, because in real time, the muscle may got damaged. I want to see that if the air muscle can also simulate the damaged muscles. So this is still the figures that we collect, the leg. On the above part, it's still not rapid part. But on the 2-hole and 3-hole, it seems like it doesn't have a lot of changes. So what caused the effect like that? So in the reality, the balloon, this is the hole we cut in here. So in the reality, the balloons were expanded on the certain amount of this direction, which looks a little bit weird, just like why the balloons inflated this side. So I'm going to also explain about this here. When we look at the balloon in here, because the neck in here being cut, meaning that the pressure from the neck, cylindrical neck itself is being shorter. And also because the atmosphere pressure is still always a constant. And the balloons inside, we assume that each time the air inside the cylindrical, inside the balloons, it will all be the same. So the changing part will always be the surface tension of the balloon itself, meaning that it will want to expand. So using the equation here, we can see that the delta P here means the pressure from the surface tension. If the delta P wants to increase, it needs to increase its radius of the ball. But the balloons itself, it doesn't have an obvious radius. So we will look at the curvature of the balloon itself. So if we compare to the last picture, you can see that the curvature of the balloon obviously increased. So meaning that this is the reason why the balloons at the end will inflate will show the way like that. So that at the conclusion part, the first thing I'm talking about is the inflating direction. Have respect with the shape of the balloon itself. And second, I'm going to say is that the cylindrical neck and the air muscles will provide like a restriction to the muscle structure. And last one, I see is that the air muscle cannot really imitate the real muscles work, because like the damaged one I made, it's not really correspond with the real muscles. So that's what my report is saying about.
Question to the reporter. Did you stretch the nest and the balloon before you do your experiment?
We didn't.
Okay. Did you visually confirm the cylindrical shape of the net?
Yes, we did that.
So you think it's cylindrical?
Yes, it is
Okay, thank you.
cylindrical.
Did you assume the balloon will have the same shape throughout your experiment? Same shape.
Same shape. It wouldn't be always.
Okay, thank you. Did you consider the air pressure and the temperature inside the balloon? It should be the same. Should be uniform during pumping.
In doing our experiment, when we use syringes to push
Yes,
the air
yes.
yes.
Okay. Do you measure the maximum shortening percentage of the net?
We didn't because.
Okay, thank you. Did you measure the volume of air needed to achieve a certain shortening?
We also didn't do that.
Okay. Will the inflation pressure control and measure? Will the inflation pressure to be controlled and measured?
The inflation pressure.
Yes, the pressure.
You mean how much will the air
Pressure.
How much the pressure is?
Yes.
What do you mean by
Can you control the pressure?
Can I control? Yes, because
Okay. Can you ensure there were no leaks in your balloon inflation?
I can.
Okay. Did you consider energy performance of this muscle?
No, I didn't.
Okay. How often do you change your balloons in your experiment?
So each time when we
How many times?
How many times? Each time when we change the variables or the
So one time.
yes, I know each different parameter.
Okay. How often do you change the net?
How often? We use the same nets as always.
Okay. Can you analyze the maximum force the muscle can generate?
We didn't do that.
Okay. Did you measure the surface tension of the balloon?
Surface tension. We also didn't do that.
Okay.
Like what I said, we're not really about cognitive.
Okay. Yes. Thank you for your answer. Honorable judges and fellow competitors, this is the opponent from Excelsior, and today I will be opponent team, question number 2, air muscle. This is the problem statement. Place a balloon inside a cylindrical net, as is sometimes used to wear garlic, and inflate it. The net will expand and shorten. Investigate the properties of such a muscle. Today we will put our focus on how is the contraction of this muscle and what different parameters can be investigated. This is the theory the reporter provides. He provides an anistrophic and isotrophic deformation and the Young-Laplace equation. And the experiment he did was the length of the different balloon and the layer of the net that is being wrapped on outside of the balloon, and also the cutting point of the net. However, there is some controversy such as friction and the temperature consistency and the shape of the balloon while the expansion. This is the strong and weak point. He had demonstrated phenomenon, and he also had a clear explanation of the causes and steps. However, he doesn't provide a boundary and doesn't compare his experiment data with the theory, which he doesn't have a theory line, and he doesn't provide a quantitative explanation of the pressure formula, and he did not measure the pressure. And however, he had compared the air muscle with a real muscle, which is really realistic. However, he didn't measure a lot of things in the phenomenon. This is the point to be discussed. Today we will focus on the force analysis because we really want to know what force is exerted on this muscle, which is the friction and the surface tension and the contact area for the balloon and the nets. And the shape of the balloon and the nets are also going to be discussed. Next, we will analyze the data of contraction and the force and the energy of the muscle. And parameters like the net width and the elasticity and the thickness and the gap of the net, and also the elasticity fatigue of the balloon and the net, and the material of the balloon will be discussed. Here are some errors like the initial shape and the length of the net has to remain the same throughout all the experiments. Also, the temperature and the pressure has to be consistent, otherwise it will affect the performance of the muscle. Also, the shape of the balloon is going to be answered since the reporter uses it in the theory. And I would like to invite the reporter.
Yes.
Can you turn to your page 7? Can you, since you use the R, which is the radius of the balloon,
Yes.
right?
Yes.
So you think the shape of the balloon is then circle, right?
Not totally. The reason why I will use this equation is mainly, I will mainly focus on the convention, just like what you said, because it's not totally a circle. So
But do you agree you can only calculate this formula if the balloon is a circle?
yes, that's
Okay,
correct.
thank you.
Wait. Hold on. You say I can only use sentence when it's totally circle balloon.
Yeah, do you agree that you can only use this formula when the balloon is in circle?
Not totally, because this sentence, it can be placed on any kind of balloon, but the radius here, it's more like an assumption of the balloon's shape.
So, did you really put data into this formula, or you just assumed it?
This is my assumption.
Okay, so the opponent suggests the reporter to really put data into this theory so he can compare the theory with his experimental data. Thank you. And this is, can I ask you, can you measure the pressure of this formula?
The reason why I will use just like what I said, I not really want to quantitate any numbers in here. I mean,
Yes.
I know the numbers of each pressure are important, but the reason why I use this part is about talking about the damage mass I want to simulate. Because I want to say that on which pressure it should be a constant, and at which pressure it will change to cause the whole, the muscles will be concentrated on the broken holes. So that's the reason I want to use this sentence here.
And thank you. So, since the opponent really suggests the reporter, like he can use the Arduino sensor to track the pressure, so you can compare, you can really get the exact number of the pressure, and you can do more further research. Okay. Can you turn to page the 15, which you mentioned about costing the properties of the net?
Yes.
Do you agree that the properties of the nets will be affected if you cut the hole out of it?
Yeah, sure.
And do you think if you cut it, it will affect the force of the muscle?
Affect the force of the muscle. Sure, you will. Sure, you will.
Do you think it will cause deviation if you want to measure the force of the muscle?
So, what does the deviation here means?
Like you are measuring the what are you measuring in this?
Still the length. Still is the length I mentioned.
Okay, and can you turn to the next page? Next.
Sorry.
Yes. What does the x-axis mean?
Sorry, I didn't put the numbers on it. This is the amount of the volume of the air I inject into
And
it.
what is the unit?
It's a millimeter.
Millimeter. Okay, thank you. And the y, I believe the y-axis is the length.
Yes, it's the length.
Okay. And how many times did you do your experiment? Since it doesn't have an error bar or a theory.
So on the rapid part, I only injected one. But on the 2-hole and the 4-hole, I injected the balloon for 3 times.
So is that the percent average of this muscle?
Static average. Yes, you can see that.
Okay. Thank you. So what do you want to prove in this?
On this diagram, at the first, because at the beginning, I think that the cutting point will just be like a real muscle because it has a tear inside. Your muscle will be, how do I say, being pulled apart. So if we look at the hose part, so my expansion on this page, the beginning, will be like the length at maybe at a certain amount of air injected, it will be like a certain drop on it, like because the net will be pulled apart, like it got severely damaged, like the real muscles. So that's why I want to use, firstly want to use figure in here. But just like what I said, the muscles become like this. This cannot really represent the whole muscles, what a real muscles would look like.
Wait, and can I ask you, how did you calculate the volume of this balloon?
How did I? Using, how do I say? I drag the syringes into under certain, how do you say that? The syringes? Because and each time I use these syringes, I drag the, how do I say maybe I call it a helmet. I call the helmets on the certain, on the same line.
So how did you measure the volume of the balloon? The volume of the balloon, since that is the x-axis. Can you turn to page 15, please? Like, how, wait. Yes, how did you measure the volume of the balloon?
So it's an accumulation of my the syringes area.
So this is the air you put into.
Yes.
Sorry. So okay. Can you turn to page 7, please?
7.
Yes. 7. Wait. Back 6. And 5.
5.
4. 5 is the force going this way.
This is just an, how to say? This isn't just an extended diagram. I want to say that what is an isotropic and isotropic cycle. I mean, it's not totally the same as the direction mentioned in here. Because isotropic means the deformation, and the deformation have respect with the direction, the force that direction put itself. But on this picture, it should be a horizontal, like the waist goes here, the structure goes here. But what I want to say in this isotropic deformation is because when you see the balloon here, it inflates at the direction, this direction. But the net also has a restriction on this direction. So meaning that it will be, how do I say, confined. I mean, if you want to use the line balloons to represent a real muscle, it should be like a 90 angle with the cylindrical net.
Okay, I get your point. So, do you think, like, as you mentioned in the short question, you didn't change the nets throughout the experiment, right?
Yes.
And do you think nets is an elastic thing?
It is. So you're asking about
So
that consider elastic fatigue of the net itself?
Do you consider in the experiment?
On the later part, I really didn't consider it. That's one of my
Okay,
goals.
so we suggest you to maybe
change the net each time.
Yeah, the next time you do the experiment.
Okay.
Yeah, and can you turn to the page 19? So what you are saying is, can you explain it again?
Okay. So this is the reason I use the sentence. Okay. So in here, the pressure from the atmosphere is fixed, and if we inject a certain amount of air inside, the balloon's pressure should also be fixed. So if we look at this part, the net, the pressure from the cylindrical net, which is the end part,
Yes.
decrease in this particular spaces in this particular unit. So meaning that the only changing part, like how does it compensates the net part, is the surface tension.
Oh, so the surface tension will decrease.
The surface tension, because the balloon is fixed, so meaning the surface tension will increase.
So okay, I got your point.
Sorry, I didn't demonstrate it.
It's okay. Can you do you think that since the problem statement mentioned cylindrical net, right?
Yes.
So do you think the nets during the process does it remain cylindrical?
It's not really always cylindrical, but I believe the cylindrical it mentioned is because when you inflated each geometric structure looks like a cylindrical.
Like no, the definition of cylindrical is like a circle.
Yeah, a circle. Yeah, for sure.
Yeah. So you didn't ensure the shape of cylindrical net was cylindrical, right? Did you use trackers to measure it?
But in the reality, could there be a totally full cylindrical net exist? Like, how do you?
This is a cylindrical net, so it should be cylindrical.
Yeah, but how to say it? The cylindrical it mentioned, it should be like a more approximately cylindrical. Because you can see
Approximately, right? But
okay,
it
if you want to go deep into the definition, then sure, it's not cylindrical.
So opponents suggest that the reporter should confirm it is really a cylindrical shape of the net during the process. So we can to be more relevant to the problem statement since it has mentioned. And may I ask you, do you think the shape of the balloon is crucial?
Of course, because I mentioned an isotropic deformation here. This is
So
why.
what is the shape of the balloon? Like the one with the smile?
The one with the. You mean the exact length of
No,
this?
can you turn to the page that has an orange balloon with a smile on it?
Yes.
What do you regard this shape of the balloon?
I will more describe it like a water drip. I mean, it's not totally circle, like what I said. It's not totally isotropic. I also have to say this. But because if we compare to this balloon, but this balloon surely is an isotropic deformation.
Yeah, so,
but this one, like each experiment I do here, you can see that on this picture and this picture, these are all in the same value. I didn't mention, sorry. But if you wrap it in the net, on an isotropic part, the net itself will restrict the balloon's from.
so it generates a force.
It generated a force that did not correspond with the air muscles.
So to investigate what is a muscle, we suggest to measure the force. This is the discussion summary. The opponent advised the reporter to provide the observation video to conduct this experiment since he had it, and we really want to see what the shape of the balloon is changing during the process. And the opponent also advised the reporter to show more graph, which provides more data and it could be more profitable. And the volume of air pumped into the balloon is not the same as the volume of air with the air muscle, since the pressure is not the same. And the shape of the balloon is the shape of the cylindrical net is not always cylindrical. So the opponent suggests the reporter to ensure the shape of the net which matches the problem statement. And the opponent also suggests the reporter use a circular balloon which we can really calculate the volume of the balloon using the radius of the circular balloon. And this is our summary. Thank you.
For both the reporter and the opponent. One source of error with that, this negative very important is leakage when you're pumping air. So how do you think we can this?
You mean the air I push it into? Yes, it's directly dragged from the air around us. How to say that? If we really can do that, want to be more accurate, then maybe we can drag the air from a pure. How do I say it? Yes.
How do you ensure that all the air is coming towards it, like none of it makes sound?
None of them makes sound because I use the three-wave valve. So when I push the cylinder, syringes at the end.
Okay, that's fine. How
What?
do you account for leakage?
Leakage. For regarding the reporter experiment or just my
In general.
In general, like preventing leakage is we can like use some rubber band to like put it on the contact area of the pumper and the balloon so it won't leak out. We try to prevent it doing our best.
Reporter, why didn't we calculate the force that the balloon is?
Because I mainly want to focus about the shape of the muscles itself. And in the statement part, it didn't mention that the air muscles needs
But
to.
when you think about the concept of a muscle is something that exerts a force.
Yes.
So why would you not include that? That's clearly part of the definition.
If you says that, then yeah, I probably agree. Yeah, maybe I should use a force sensor under the package force. I agree with your points. Yeah.
So when you mentioned that they missed a lot of measurements, like what are parameters? What's the most important parameter?
We think it's the length of the cylindrical net because if it is shorter, it generates bigger force because it is easy to let the net limit the balloon so it generates a tension which has a force and a certain tension.
You also mentioned pressure. So
Yeah.
if you were to vary the amount of air you pump, how would that change the experiment?
Can you repeat the question?
If you change the amount of air you pumped into the balloon,
Yeah.
how would that change the experiment?
We think it will change the volume of the balloon and the volume of the balloon will affect the force of the muscle.
Right. And have you considered that the net may deform over time?
You mean this what elastic fatigue? Yeah, is that what you mean? Just like what I described, I still didn't change the net on each layer, so that's the weakness point of mine.
I'm Stephen, and I'll be reviewing topic 2, air muscle. So this is the problem statement, and our reporter, they decided to focus on narrowing the number of layers and how that affects the contraction of the balloon, and they also change the length when you cut holes into the net. Here is what the reporter did. Their phenomenon was they compared the balloon to a real muscle, including tears and stuff. They restricted the balloon's expansion, and they said that it causes contraction. And then they said, and during their experiment, they controlled the material and structure of the net to simulate tear of the muscle. Some of the pros were that they had good definitions, they had a clear voice when talking, they had visuals to represent their ideas, and they had interesting mention of real muscles. However, they had no focus on the title slide. Their focus literally had 10 slides into the presentation, so it's really hard to follow. It was an unclear shape for the experiments, like is it spherical, is it cylindrical, which balloon are you using for which experiment? It was really unclear. There's an unclear definition of what multiple layers mean, what even is taking off one layer. There's no mention of important parameters such as pressure and volume, which could affect the force of the system. And there's no axis titles for the graphs, which is really hard to understand. The purpose of the experiment was unclear. They just said they were describing how a muscle would act, but there's no numerical values. There is no discussion of the force that the balloon exerts, which is a key part, as I mentioned during our discussion, because muscles have to exert force, and they have a lack of error analysis, such as things like leakage. And for the opponent, the summary of their discussion was that they discussed unclear shape of balloon, they suggested fixes and analysis, and they discussed other potential parameters. They spoke with a clear voice, they discussed measurements that the reporter missed, and they also discussed other possible errors in their experiment. And overall, it was pretty good, but it could have been more structured. And the first discussion was balloon shape. The opponent asked, what is the shape of the balloon? The reporter says the equation assumes that the balloon is a sphere, and I believe that the reporter should be more clear on the shape during the calculations and experimentation, so that it both fits the problem statement and also you get the right calculations. The second discussion was pressure. The opponent suggested to track pressure using Arduino. The reporter said they didn't consider it, and we agree with the opponent because pressure is a key factor that contributes to energy in the system, which the reporter completely disregards. And cutting nets. The opponent says cutting holes will affect the force of the muscle. The reporter says yes. Since they answered yes, so why wouldn't they calculate the force of the different nets? I don't really understand that. And then the opponent asked, what do you want to prove your experiment? And they said to simulate real muscles. And the reporter has a lack of numerical data, even though they describe the behaviors. And they pretty much did not mention characteristics such as force, which is a key factor. They also discussed like axes and graphs. They said it was millimeters. And here are the points that they had missed. They could have had more emphasis on critical values, like when the balloon would pop. Since they wanted to replicate when the muscle would tear, I think it's pretty weird to not discuss critical values. And the rate of pumping and how it affects force was not deeply explored here. And overall, they did not explain the shape of the graph and how the trend overall makes sense in the physics context. Thank you.
Okay, so here's the concluding remark of the whole ear muscles. So first one, still we focus on how to simulate with the real muscle, but to quantify the parameter. I do believe that, like what you said, to quantify the parameter is also another way to have a research in the air muscles. And second one, we think that cutting a hole on the neck can cause different force onto the system, just like what I said. It's like air will be concentrated on the broken part. And also thanks for the suggestion for changing that in every time I didn't consider the elastic for me. That's also my fault. And the second is also thanks for the suggestion for using force sensor. Yes, force is an important parameter. I eventually agree with that point. And the last one about the cylindrical part, I believe that they couldn't find a real cylindrical one. I mean, even though at the end your net will be cylindrical, but if you want to create the muscle behavior, the geometric structure of the net must be changed. It couldn't be like how you gonna change a cylindrical net with it, not being tightened. The muscle has to become that. So I believe that the cylindrical net I use is as the same as it mentioned in the problem statement, because it also said that sometimes you use guarded. I mean, the one I use is really to use, just like the problem statement said. Okay, so that's my concluding remark toward the whole debate. Sorry. Okay, that's it.
Okay, questions on the theory? Yes, just have a question for all the parties.
describe the pressure. Right? One parameter for the neck, one parameter for the surface, right?
Yes.
So how do you judge that?
I think the reason why I used only use these two parameters because I think it's the main force that contribute to the how to say the air being how do I say concentration on the broken hull. So there must be have other factor in it, but that's why I didn't consider inside. Like maybe there's a friction between the nets.
I think they missed the most important aspect, which is pressure, because it determines both the expansion as well as the force that the muscle exerts.
You mean the force?
Pressure.
So calculation of pressure. We think we can just calculate the pressure of the balloon using Arduino sensor, and we can get the actual data, and we can put it into the theory.
So I have a question. So the reporters say that we want to mimic muscle, right?
Yes.
And you talk about an isotropic ratio. Do you know what's the anisotropic ratio of the real muscle?
Isotropic ratio.
Because you talk about an isotropic expansion and contraction. Do you know what's the number?
I have research in that. I use this more because it has this trait. I didn't have the real numbers inside.
So yeah, the same question for the opponent and the reviewer. Do you think that this problem is to investigate an isotropic property of the balloon?
I agree.
You agree? And do you?
Yeah, go ahead.
Do you agree?
I believe they should have research more deeply into the numerical values of real life muscles so they can have a more accurate comparison between the balloon and actual muscles.
So do you know the anisotropic ratio of this
No, I
real
do
muscle?
not. No, I do not.
How about you?
I don't, but I think it could be investigated.
Muscle should be dynamic, phenomenal, right? And all the three, how do you study from this problem? How do you really get this dynamics in place? Because in your experiment, you only inject certain volume of this air.
Yes.
And you measure this kind of state. You have three data points, so you get 3 times. And you measure it's only a scale. You measure the mass.
So you mean are you asking about why I use length to describe the
Well,
motion?
I mean, your experiment is more like a static experiment.
Yes, it's not in the. Oh, I got your points. Oh, yes, the real muscle, its work should be in a dynamic form. How do I say it? How do I feel that? So you
That's what I asked. You have that theory.
So how do I detect the dynamic form of the muscles? I think it will be. I mean, compared to the way I do experiment, I detect each point at a certain value. Maybe it's like maybe I can draw red points at the end of the balloons and just detect how the end moves from fixed at one point and see its motion. I think maybe that's the way I do it.
I think you should record the process of expansion using 3 different cameras tracking the X, Y, and Z axis to come up with a 3D model.
I think the reporter should investigate like the energy efficiency and the force of the muscle, because that is the real definition of muscle, because muscle is used to lift up things, and we should consider the energy efficiency. Like when you lift up a thing, what is the distance you lift up? It's not
How
just
you break it by the energy efficiency.
not just the force. Like when you lift up something by muscle, we could also consider how what is the distance it lift it up, and that is the energy it produces.
Should we declare the score? Score for the reporter, 6, 7, 7, 6, 6. Score for the opponent, 7, 9, 6, 8, 7. Score for the reviewer, 7, 8, 7, 8, 8. Okay. Thank you.
好，请进所有的presenter 带着你们的电脑来，我们要 copy 一份你们报告用的 PPT。